Hey everyone, just a quick update and some notes. These, okay, so these that you see here, you can see that I've got a color system going. This cactus here is something that is, it's got a sine wave that slows it down, allows it to go up like that. And I've been messing with these systems for particles. And I was thinking about most games have particle systems, most engines have particle systems, so doing something like hair with dynamics like this one, or without dynamics like this one, like a cactus or something, but also that the cells themselves, inside of a mesh, you can set up a particle system that like allows you to draw the particles like this. Particle edit. So not only does it allow you to like cut or lengthen, puff it, things like that. Like I could seriously, because Blender is just great like that. This one I've let it change over time, right? It just does dynamics with, okay, puffs back out a little bit and then comes to a, so pretty much in Blender you can use in a particle system, you can use any sort of a hair or emitter or whatever, right? And I think somewhere down here you can have it as a certain material, all that other stuff, right? But also there's a way to show another, I don't know exactly, hair shape? No. Could be one of these. But basically what happens is you can set a mesh for this instead of just like hairs or whatever. So instead of emitting like these fibers, let's let that sit. Okay, so instead of emitting like these fibers, basically what it would emit is some sort of a, like, let's get those little hairs off the bottom of that guy. Doesn't need those hairs there. Okay, now let's see what happens. Oh, what? Particle edit. It's not doing, oh, it's because they bake, the stuff is baked. Anyway, the point is that if we get this this particle system working right, what can happen is these cells can emit specific particles, and those particles can be meshes, for instance flowers, leaves, whatever, and all those have to be are these, like this set of 3 different types of parameters, or could basically, so that inside of, for instance, at this level, for instance, at this level, you could have something going on with the, let's say right here, right? Something could come out of here that is shaped like a flower, is shaped in any sort of way. Like it's basically the start of a whole new set of parameters, of themes. So I've started to figure out some of these pieces of nomenclature, so to speak, for this for the genetic type stuff. So basically you've got well, okay, so over here you've got this, like, that's weird. Okay, 0.9. Anyway, so you've got this whole thing set up. I've explained this in a previous video. What this does is create basically one of these, right? In different ways. And then the whole idea is that yeah, okay, that one's having a bad hair day. The idea is that this here, all of these parameters step through, okay? And what that means is that once they're stepped through, like, it changes the way that the branches beyond it behave. In previous videos, I've shown things where I use different functions for these different cell parameters and the start radius stuff for the slice, and that really shows in differentiation of shapes and stuff. So while that is great, there needs to be a secondary step mechanism where it's going to go next, but in this case, it's going to create something on top of the tips that already exist in all of these points. And you can see them as open here. So these things can be temporal, and they need to work on a cycle system, so that so basically there needs to be like another set of instructions with them that goes along with them that says something like, okay, at this specific branch level, start, and at this specific like time of growth period or something like that. It might not be in growth steps, because growth is technically a different thing. That's called vegetation in biology. Growth itself doesn't need to be happening. It can happen step by step, and these steps can then be the cells can have other things that it does, like these actions that it can take, where it can move, or whatever. All of these pieces can be taken apart. They can move. Really, it can get pretty weird for sure, because of all the different shapes and stuff, and it can move around and things. But at the same time, I'd like to take advantage, just in this, to sum up this video note, I want to take advantage of the particle system in most video games, and maybe a standardized one or whatever, to build it into my core library. But that's what I want to do, so that it takes the so that, for instance, only some of these cell faces would have spikes, or only some of these parts of this tree would have these particles that are coming off of it, and these could obviously be any type of thing, right? So I could actually make little nodules that show up or something, or I could even make a tree that, if I could get a good enough control over the particle system in such a way that it was standardized enough so that it would work in Unity, in Blender, and in Unreal. I might be asking for too much, who knows, but if I could do that, then I would actually be able to have it so that I could, you could see particle, okay, so there could literally be cells on here on certain points that just emit light, little light things that come off or whatever, or that emit a fog of something into the air, right, in these particle systems. And technically, inside of Blender and inside of other systems, those particle systems have physics of their own. So that means that I can do stuff these things could emulate sort of any type of thing that has to do with particles, or making temporary changes over time, and all of those changes can be controlled by the parameter system, as well as the things that happen that are standard inside of particles, which have to do with going. Okay, so there's all kinds of stuff in here that you can edit, right? Let's go back over here. Boom. If you run that really, that's so crazy. If you run that, yeah, wow. Okay, anyway, so the point is, let's go over here and let's just like let it fall in what should be like calculated as real time inside of the simulation. Okay, so now the base, like we've cut the hair off the base or whatever, but it's still like popping down a lot. So, you know, obviously some of these cells you can draw on here. There's a way in Blender and quite possibly in other systems to draw like a map, just how I have color. By the way, these colors are done by age of the cells themselves. So, of course, since these cells are set up radially around, you see these rings form. I could blend those further into each other, but I have them set up so that you can just see the difference between them. And this is what I'm talking about when I say the plane of the cell, because each cell has a face, okay? That face belongs to like this cell or something like that. I don't know exactly how it works out in the in the advanced math of what this is actually like calculating, but I do know that one of these cells is the cell that's responsible for the color of this face, so I can do the same thing on a face for any particle emitter. So I could make like little bubbles that come out. I mean, anything that you can imagine, and that can be all set up on the same type of parameter, infinite curve type deal, where sometimes it happens and sometimes it doesn't. And then if you think about it, those can be like actions that these tips can do. And the tips can have these actions that like allow it to change to a different set of parameters at this point in time, and then it just starts like making something completely different on the tips of whatever this is, and that's all just part of the DNA. And the only thing that you would need to know is pretty much when, like the DNA would need to, like the genetic, whatever it is, the builder, I'll just call it the builder, the architect of this thing, which is just the entire set of all these cells together, which makes up the mesh, right? But that architect can decide when to switch to that or not, or it can be set on one of these like function curves at a certain frequency, for instance, a sine wave at a certain frequency. And then it could be like, if this like grows, then it can also, something grows up here or whatever, then it can also like wither or die, fall off, or disappear somehow, or change to something else. Like that all is going to be based, though, not inside of the DNA. That's going to be based off of the actual hormone interaction between the cells, which is going to be, I'm going to get to that, and what I'm basically going to try to do is make an animation. This is going to be like my first animation of cells which show the color, like they can show the color of like what frequency of what thing is being communicated between them. So you can sort of see, just like in those plant movies where you can see like this energy moving through the plant, or what are these different frequencies of energy moving through the plant. I want to have the same type of deal here going on, because that's the way that these cells communicate, is locally and through the surface, and that's the way that they grow together anyway. So their communication system is going to be based on that. Anyway, so that's the video. Let me know what you think. If you have any ideas or whatever, just let me know. If you're in the Discord, just let me know in there. And yeah, until the next time. And I should have something on this. Like, there's a lot of stuff to build, so the roadmap going forward is on the GitHub page, which is also it's linked below. Please like and subscribe if you like what I'm doing. I'm trying to share this with the community so that you guys can pop in at any time and just say hi or whatever, or even if you're a developer, come on in. I welcome forks or anything. I don't want proprietary stuff to take over the metaverse, and I want natural things to show up in the metaverse that show us, that illustrate to us what a gift life is. Anyway, so not to go too far, off into stuff like that. Yeah. You guys have a great Christmas if I don't make any other videos. Great Christmas and New Year's. And stay safe. And until next time.